Hello and welcome to my channel. In this video we are going to solve a past paper question from Circle Theorems which had appeared in Edexcel GCSE Maths Higher Paper 1, which is a no calculator paper. So let us start with the question now. A, B and C are points on the circumference of a circle with center O. DAE is a tangent to the circle at point A. Angle BAE is equal to 56 degrees. Angle CBO is equal to 35 degrees. Work out the size of angle CAO. You must show all your working. So here we have been given a circle whose center is at point O. Now there is a tangent DAE that touches the circle at point A. Now remember that the tangent touches the circle at only a single point. So in this case it is touching the circle at point A. ABC are the points on the circumference of the circle and the angles are being given to us. We need to find out this small angle, angle CAO. So to begin with, let me consider this figure over here for easy reference. So here we have reconsidered the given figure. So here angle OAE is written as 90 degrees because of the radius tangent theorem. Remember that the radius, now in this case OA, OB and OC, if we connect these 2 points as well, represents the radii of the circle. So according to the radius tangent theorem, the radius always makes a 90-degree angle with the tangent touching it. Now here OA is the radius and DAE is the tangent. So the radius makes a 90-degree angle with the tangent at point A. So here we can also draw it this way. So angle OAD also becomes 90 degrees. Now here let us focus on this angle. So here we have written, according to the radius tangent theorem, angle OAE will be equal to 90 degrees. Now once we have got this, let us focus on finding the angle OAB, that is this small angle. Now since we got to know that angle OAE is 90 degrees angle, and here in the figure it is given that angle BAE is 56 degrees, we can find this small angle OAB by subtracting this 56 degrees from the 90 degrees. So here we have written angle OAB is equal to 90 degrees minus angle BAE. So this angle is given as 56. So 90 minus 56 gives us 34 degrees. So this small angle OAB, now we got it as 34 degrees. Now once we have got this angle, let us focus on the triangle OAB. I have highlighted the triangle over here, that is OAB. Now here we have written, consider isosceles triangle AOB. Now it is considered as an isosceles triangle because we have two of the sides same in this triangle, because OB is the radius of the circle and OA is also the radius of the same circle. And since these two sides are same, the angles opposite to these two sides are also going to be same. So here we have written angle OAB will be equal to angle OBA. So this small angle is also going to be equal to 34 degrees. Now let us focus on the triangle ABC. So here we have written, consider the triangle ACB. We have highlighted the triangle over here. Angle ABC is equal to 35 degrees plus 34 degrees. So this total angle ABC now becomes 69 degrees. Now once we have got this angle, let us try to find out the angle ACB. And for this we have to make use of a circle theorem, which is alternate segment theorem. It states that the angle that lies between the tangent and the chord is equal to the angle made by the same chord in the alternate segment. So let us try to understand this statement. You can see that we have drawn a circle over here and AB represents the tangent touching the circle at point B, and we have drawn a chord BC inside the circle. This chord divides the entire circle into two segments. One is this small segment called as the minor segment, and the other is this larger segment called as a major segment. Now let us say that this chord makes an angle of 30 degrees with the tangent this way. So this is just an example. Now let us make an angle using these 2 points on the chord in the major segment at point D. So let us consider these 2 points of the chord and let us say that this chord is making an angle at point D in the major segment. Now according to the given statement, the angle that lies between the tangent and the chord is equal to the angle made by the same chord but in the alternate segment. So here, if this chord is making an angle in the minor segment, the same chord is going to make an angle of 30 degrees in the major segment. So this angle is also going to be 30 degrees. Now let us see how we can use this theorem to solve the example above. Now here, let us consider the tangent DAE and let us consider the chord AB. This chord AB divides the entire circle into two segments. One is the smaller segment called as the minor segment and the other one is the major segment. Now we can see that this chord AB makes an angle of 56 degrees with the tangent in the minor segment. So the same chord is going to make an angle at point C in the major segment. So this 56 degree will also be equal to angle C. So angle ACB will be equal to 56 degrees. So here we have written angle ACB will be equal to 56 degrees, that is by alternate segment theorem. Now we have got two angles of this triangle, that is angle B and angle C. Now let us try to find out this angle A by using the angle sum property of a triangle. So we have reconsidered this figure over here for easy reference. And here we have written, using the angle sum property of triangles for triangle ABC, angle A plus angle B plus angle C will be equal to 180 degrees. Now since we are trying to find out angle A, we are going to take angle B and C, whose values we have got on the other side of equal to sign. So angle A will be equal to 180 minus angle B plus angle C. Now here we have written the values of angle B and C. So 180 minus angle B is 69 and angle C is 56. So 69 plus 56 is going to give us 125. So 180 minus 125 is going to give us the value of angle CAB as 55 degrees. Now once we have found the value of angle A as 55 degrees, now it becomes easy for us to find out the value of angle CAO, that is this small angle over here. Now since we have got this angle, that is OAB, as 34 degrees over here, as you can see, we are going to just subtract this 34 degrees from 55, giving us the value of angle CAO. So here we have written angle CAO is equal to angle CAB, that is this total angle, minus angle OAB. So here we have written the total angle is 55 minus this small angle is 34. So 55 minus 34 gives us the value of angle CAO as 21 degrees. So this is our answer. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.